myself Rakhi, Assistant Professor in the Department of Electronics and Communication Engineering, ABS Engineering College, Ghaziabad, affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. Today in the lecture series of Microwave and Radar Engineering, I am going to teach you microwave hybrid circuit, and in that section we will go through the 3-port Tees. Now, first of all, the microwave hybrid circuits. The microwave hybrid circuits are basically consist of several microwave devices connected in some special way or in some different way so as to achieve a desired transmission of the microwave signal. So, the main purpose of this microwave hybrid circuit to join the different types of microwave devices and obtain the signal in that direction and in that value which we want according to our requirement. So, these are basically designed for specific requirement purpose. So, microwave circuit ordinarily consists of several microwave devices connected in some way to achieve the desired transmission of a microwave signal. The interconnection of two or more microwave devices is regarded as the microwave junction, and in the common example of this are E-plane T, H-plane T, magic T, circulator, isolator, directional coupler, the numbers of the microwave hybrid circuit which exist. So, just for example, two diagrams are mentioned here. The first one is the E-plane T and the second one is the magic T. Now, before the analysis of any microwave hybrid circuit, we have to discuss about the S parameters. Already we have in the network, when we have a 2-port, we have discussed about the number of the parameters. For example, H parameters, Y parameters, Z parameters and the ABCD parameters. But all these network parameters relate what? Voltage and current at each of the 2-port. But at the microwave frequency and microwave range, this parameter can't be measured. And there are specific reasons for that, why we can't use these parameters at the microwave frequency. And when we talk about your examination point of view, so this question comes, why we don't use the H, Y and Z parameters at the microwave frequency. So, there are 3 points, you should remember that 3 points. So, first one is the equipment is not readily available to measure total voltage and total current at the port of the network at the microwave frequencies. The second one is short and open circuits are difficult to achieve over a broad band of frequencies in the case of a microwave frequency, that is why it is not used. Then the third one, active devices such as power transistor and tunnel diodes frequently will not have a stability for a short and open circuit. These are the 3 reasons why we are not using the H, Y and Z parameters at the microwave frequency, and we have to switch towards the next level of parameter, that is the S parameters. The logical variable to use the microwave frequency are travelling wave rather than the total voltage and the total current. So, what we are actually using at the microwave frequency? Travelling wave rather than using the voltage and the current. So, the expressions of when we have this 2-port network like this, there is a generator, there is a impedance at the input end, there is a load. So, A1 input, A2 input here, B1 and the B2. So, B1 and B2 are taken as the our output here, and the A1 and A2 are taken as the input. And then we talk about the output. When we write then the output, then the B1 is equal to S11 A1 and B1 is equal to S12 A2 and B2 is equal to S21 A1 plus S22 A2. This is the general expression for representing the S parameter. Now comes the case of a waveguide Tees. In a microwave circuit, in a waveguide or coaxial line junction with 3 independent ports is normally referred to as a TEE junction. So, any waveguide or coaxial line junction that means it is point where 2 or 3 waveguide join. So, and when this there are 3 independent ports, then that is refers to as a TEE junction. So, first of all, before going through the Tees, various types of Tees exist. first of all, in general characteristic of a 3-port junction, and these are the 3 theorems which is applicable for any T junction. First one, a short circuit may also be placed in one of the arms of the 3-port junction in such a way that no power can be transferred to the other 2 arms. The first theorem is that if a short circuit can be placed in one of the arms, that means a T has a 3 arms, already 3 independent. So, there exist 3 arms. If we say 1 arm, 2 arms and the 3 arms. So, if we apply the short circuit at one of the arm of a 3-port junction such that no power can be transferred through the other 2 arms. So, in that case, no power will be transferred. If we apply the short circuit at one, no power will be transferred to the other 2. If the junction is symmetric about one of its arm, the short circuit can always be placed in that arm, so that if the junction is symmetric about one of its arm, in that case short circuit can be placed in that arm only, so that no reflection occur in a power transmission between the other 2 arms. So, if we want that there should be no reflection occur in power transmission between 2 arms, so we have to apply the short circuit to that arm which is symmetric to the junction. And the third one, it is impossible for a general 3-port junction of an arbitrary symmetry to represent matched impedance at all the 3 arms. So, it is impossible for any 3-port junction to have a matched impedance at all the 3 arms. That means S11 is equal to 0, S22 is equal to 0, S33 is equal to 0. This can't be possible in the case of a waveguide. So, these are the basically 3 theorems related to the any T junction. Now, basically the most important T junctions are 3-port T junctions basically. 3-port T junctions are E plane T and the H plane T. E plane T is also known as the series T. So, first of all let us see why it is called as this. A E plane T is a waveguide T in which the axis of its side arm. So, what is the side arm? These are basically collinear arm port 1 to port 2. These are the basically the main arm, main waveguide we can say, and this is the our auxiliary waveguide. Actually, I am saying this to you because this term will come further also. So, and these are the collinear one, port 1 and port 2. E plane T is a waveguide T in which the axis of its side arm, so this is our side arm, is parallel to the E plane of the main guide. So, side arm should be, this is a side arm and this should be parallel to the E field of the main waveguide. So, if we want to construct the E plane T, in that case first of all we take a main waveguide and see the flow of electric field and the magnetic field. In that case we will, and if we want to construct the E plane T, so we will put the side arm parallel to the E field of the main waveguide. If the collinear arm is symmetric about the side arm, there are 2 different transmission characteristics. And if the E plane T is perfectly matched with the aid of, these are basically the method by which we can match the any T. With the aid of screw tuner etc., the diagonal component of the scattering matrix is 0 because there will be no reflection. So, what is basically saying here, when we have a 3-port, so basically when we have any 3-port structure, in that case we have 3 cross 3 matrix. We will have a 3 cross 3 matrix because there exists a 3-port. So, when we write the 3 matrix S11, S12, S13, S21, S22, S23, S31, S32, S33. So, what is saying here, that if we matched all the perfectly matched all the ports, in that case the diagonal matrix, that is this one, will be equal to 0, that is S11, is equal to S22 is equal to S33 should be equal to 0, and this is applicable for the matched load only. But one of the theorems says, if you see the last theorem here, it is impossible. So let us see what is going to happen now. Now, this is a general property of a E-plane T. So till now we have studied about the properties of that is applicable for the all the T's. Now the first, that is for the E-plane T. When the waves are fed into the side arm, that is port 3 is our side arm. We are assuming that the port 3 is a side arm. The wave approaching at port 1 and port 2 of collinear arm will be opposite. That means S13 is equal to minus of S23. So if we are feeding the power through third port and it is entering the port 1 and port 2, that means both will have the same magnitude but the direction will be different. And for the matched network, already we have discussed that the diagonal matrix will be equal to 0, everything will be same. Now, for getting the complete matrix of a E-plane T, we have to apply some of the properties of the S matrix. Then the first property is the symmetry property. For that, S12 is equal to S21. That means symmetric properties say Sij is equal to Sji. This is our symmetric property. So S12 is equal to S21, S13 is equal to S31, S23 is equal to S32. Now this is our symmetric property, and from the zero property of a X matrix, what the zero properties say, the sum of the product of each term of any row or column. So let us see. This is a 1 is multiplied by the complex conjugate of the corresponding term. So let's see the complex conjugate. We have taken, and now we are multiplying it. S11 is multiplied with S12 conjugate. S21 is multiplied with S22 conjugate, and S31, this one is the S31 and is multiplied with S32 conjugate. So when we have this one, what is going to happen here, that we are assuming that this one and this one contain S11 and S22. S22 are 0 basically magnitude. So now S13, we can by the symmetry property, this 31 should be written as S13 and S conjugate 32 can be written as S23 should be equal to 0. So this is the conclusion which we are getting. Now what does it indicate? That either of the S13 or the conjugate of S23 should be 0 or both should be 0. Now from the first property, the symmetry property, second one is the 0 property, and the third property comes, that is the unitary property. So as per the unitary property, what does it say? That sum of the product of each term of any one row multiplied by its complex conjugate is unity. So in that case, S21 multiplied with S21 conjugate, similarly S31 multiplied with S31 conjugate. S11 multiplied with S11 is taken as 0 because we are considering here a matched network. So that will be equal to 1. Now we take the second one, S12 multiplied with S12 conjugate, S22 multiplied with S22 conjugate, but S22 is 0, that is why it will be taken as 0, S32 multiplied with S32 conjugate. Similarly the third one. Now we are having this three equation. Now from the equation 1, what we are getting here, this is our equation 1. So, S12 is equal to 1 minus S13, this one. Now, S12, since S21 is equal to S12. Now, from the equation, this is from the equation 2, from the equation 3, S12 square is equal to 1 minus, for S32 we can write 2, 3 by the symmetry property. So, this is our equation, but this is the equation 5 here. From the equation 2 and 3 we are getting this, but when we look over the equation 4 and 5, don't you think it is contradictory to each other? Since here what we are getting, and from equation 4 what we are having, S13 should be equal to 1 minus S23 whole square. But here what we are getting, this one, according to this equation 5, S13 should be equal to S23, but here it is from equation 4, we are saying that it is not, can't be possible. So, equation 4 and 5 are contradictory to each other. Again we are saying that equation 5 says S13, 1 minus S13 square should be equal to 1 minus S23 square. According to that, both S13 and S23 should be equal, but as per the equation 4, S13 mod square should be equal to 1 minus S23 mod square. That means these two equations are contradictory to each other. So, either of these equations will be false. So, if we are assumed that the equation 4 is false here, similarly, if we say that S23 is equal to 0, then S13 also becomes 0, and therefore, equation 5 is not true. That means consistency is disturbed in the case of equation 4 and 5. So, the statement, this proves that the statement that the junction cannot be matched to the 3 arms is justified, because all these values which we are getting here is based upon the assumption that S11 is equal to 0, S22 is equal to 0 and S33 is equal to 0. So, when we completely solve it based on this assumption, then we are getting a contradictory result. Now, so in general constructed of an empty waveguide, it is purely matched at the T junction. This can't be 0 if I equal to 0. So, since the collinear arm is usually symmetric about the side arm, so S11 should be equal to S22. So, the matrix S11, S12, S13, S21, S22, S23, S31, S32, S33. What we are getting? S11 as it is, S12 as it is, S13 as it is. At the place of S21 by the symmetry property, S12. We are saying that the terms are collinear. So, S11 is equal to S22. So, S22, S11. By the E plane T, what is the first we are getting? That S13 should be equal to minus of S23. That means that S13, when the signals are fed in the third port and it is coming out of the port 1 and the 2, the magnitude will be same, but the direction will be different. So, if we are saying S13 is equal to minus of S23. Now, S13, we can also write it S23 should be equal to minus of S13. Minus of S13, that is why here S31, S13 by the symmetric property, S32 by the symmetric property it will be S23, and by the property of a E plane T it should be equal to minus of S13, and S33 remains the as it is. So, here comes the end of a E plane T. So, what we have done here, again for the recap purpose, because this is a very important part, E plane T, three poles, that's why 3 cross 3 matrix should be applicable here. And here we have the first property of a E plane T, that is S13 should be equal to minus of S23, and if we assume that all the 3 ports are matched, these are the equation. Now comes the first property, second property, that is symmetry property. Sij is equal to Sji, this one. Now comes the zero property, through which we getting that this one. And now third one is the unitary property. From here we are comes to the conclusion that it can't be possible for all the 3 ports of a E plane to be matched. So after that conclusion, we are obtain the matrix of a E plane T. Now the H plane T, that is also called as shunt T. The H plane T is basically again opposite of the E plane T. In this case, what is going to happen? In the E plane T, the side arm is constructed at the direction where we have a direction of the electric field of the main waveguide. So, axis of the side one is shunting the E field or parallel to the H plane of the main guide. In first one, in the E plane, is side arm is the parallel to the E plane of the main guide or the electric field, and here the H plane. And in this case, if two inputs are fed in port 1 and port 2 of the collinear arm, the output at port 3 will be in phase and in additive. So, if we are providing the signal to the third arm and it is coming out of the port 1 and 2, that means they will be in S13 should be equal to S23 because they are in phase. This is the difference between the E plane T and the H plane T. In the E plane T, they are not in a phase. That is why S13 is equal to minus of S23. But here S13 is equal to S23. So, the only difference which exists in the S parametrics of a E plane T and the H plane T is that this one here we have when we write the this is the matrix in general. So, S11, S12, S13, S12, symmetric property, 2-1 change into the N12, S22 collinear arms changes into the S11, S23, S23 is equal to S13. But when we take when we see the E plane T, in that case here it is minus of S13. Okay. Now comes the S31 by the collinear property, symmetric property, this will be S13. This is S32 by symmetric property, it is S23, and by the property of the H plane T, it will be S13. And this is again the difference between the H plane T and the E plane T. For the E plane T, it will be minus of S13 and S33 same. So, these are basically the end of the S-matrix analysis of the E plane and the H plane T, and in your examination the analysis of the E plane, analysis of the S parameter analysis is also asked, and this is a very important for generalizing or understanding the proper function of the E plane T and the H plane T. So, here comes the end of your E plane T and the H plane T. In the next class, we will continue with the 4-port T. There also exists a 4-port T. Till now, we have commented the 3-port T. In the next lecture, we will continue with the 4-port T, that is our magic T and the hybrid Ts. And after that, we will have the other microwave hybrid circuits. Thank you for attending today's class.